Hello everybody, today I present a video entitled The Matrices Part 1. We are going to see some definitions and examples about matrices, the addition and multiplication of matrices, and the product of a matrix with a scalar. First, we define a matrix as follows. A matrix is tabular, contains numbers, and each element has a position. For example, this element is the element of the second row, the third column. Now, we give some properties about matrices. So, the interesting thing in these properties is the size of a matrix. We know the size of a matrix of m rows and columns by m times n. And if m equals n, then the matrix is called a square matrix of order n, or of the degree n. We give some examples. Here the size of the matrix A is 3 by 5. The elements of this matrix are: for the matrix B, it has 3 rows, 3 columns. So this matrix is called square matrix of order 3, and its elements are: for the matrix addition, we can add two matrices of the same size, and the sum is a matrix. Its elements are the sum of the corresponding elements in the same position. These properties are true in the subtraction process by subtracting corresponding elements. We give an example to illustrate the process. We have two matrices of the same size, so we can compute the addition. So the matrix of addition equals. We have also the following remarks about addition and subtraction of matrices. Now, for matrix multiplication, we can compute the product of two matrices if and only if the number of columns of the first matrix is the same number of rows of the second matrix, and the product is a matrix has a number of rows of the first matrix and the number of columns of the second matrix. And the elements of this matrix are given by the following formula. We will illustrate the operation in the next example. So, we want to compute the product A times B. The size of the matrix A is 1 by 3, and the size of B is 3 by 2. So, we can find the product and we will get matrix 1 by 2. The number of rows of the first and the number of columns of the second. We compute the element of the first row, first column. For this, we take the first row of the first matrix and the first column of the second matrix. We multiply the first element of the row with the first element of the column, plus the product of the second element of the row with the second of the column, plus the third of the row with the third of the column. We get the element of the position first row, first column. For the element in the first row, the second column, we compute the sum of the products of elements for first row of the first matrix and the second column in the second matrix. For the second example, we give a method to find the product by using a tabular. So we write the first matrix in the product in left and the second matrix in top, and we compute the elements as follows. For the product of a matrix with a given number we multiply each element of this matrix by this number.